In this video, we will learn how to graph exponential functions such as these without using a scientific calculator. Alright, we'll start with number 7, 3 times 2 to the x power minus 6. Now I've got my table down here. Maybe I better write this down. So this is going to be 3 times 2 to the x power minus 6. Alright, that's how we will get our y values. We will start off using the x values of -2, -1, 0, 1, and 2. Alright, those are always good x values to start. They're just centered around the origin. Why not? Now, when I find these y values, first I'm really just going to do the 2 to the x power part. That's all I'm really going to put here. I'll do the 3 and the minus 6 later. So 2 to the x power, you say. So remember, that means I'm doing 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 squared. 2 to the -2 power, that is 1 over 2 squared, so that's going to be 1 over 4. 2 to the -1 power is just 1 over 2. Anything to the 0 power is 1. 2 to the 1 power is 2. 2 to the second power is 4. Notice how the ones on either end are reciprocals. 1/4 and 4. 1/2 and 2. With 1 right in the middle. That will always happen, so use that to double check yourself. If you're not getting reciprocals, you're doing something wrong. Okay, so far we've done the 2 to the x power part. Now, we haven't done the 3. That 3 is a vertical stretch by a factor of 3. And whenever you have a vertical stretch like that, an a value, we call it, you need to make a new y column to reflect the vertical stretch. So I'm going to make a new y column like this. Not sure why I made it quite that big, but whatever. So, because the equation is really had this 3 here. It's 3 times 2 to the x power minus 6. So that's why in this column we will do 3 times all the y values. So 3 times 1/4 is 3/4. So to be clear, I'm doing 3 times 1/4, and that's like having 3 over 1. And I'm just I'm multiplying straight across. 3 times 1 is 3. 1 times 4 is 4, so that's why it's 3/4. Similarly, 3 times 1/2 is 3 over 2. And then 3 times 1 is 3, 3 times 2 is 6, and 3 times 4 is 12. Alright, so these are the values. If you need it, 3/4 is the same thing as 0.75. 3 over 2 is 1.5. If that helps you to graph, then so be it. Once you have a new y column, you can go ahead and disregard the old y column. So that's all we're going to do so far. We will do the minus 6 part on the graph itself. But let's go ahead and plot these points. So I've got -2, 3/4, okay, or 0.75. So if I plot that, alright, so -2, and then 3/4 is going to be like here. Okay, and then I've got -1 is 1.5. So at -1, I'm at 1.5. So that's right there. And then 0, 3. So here we are, 0, 3. And 1, 6. So 1, 6. And then 2, 12. So 2, 12. Alright, so we have not done the minus 6 yet. That's the only thing that's missing. So minus 6 is down 6. So I'm going to take each of these points and I'm going to move them down 6. Okay, so if I do that, that's going to be 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Just moving them all down 6. 1, 2, 3, 4, 5, 6. Alright, this is up 6 already, so if I move it down 6, it'll be right there. This is at 12. So if I move it down 6, it should be right there. Okay, also, the asymptote. The asymptote used to be at 0. That's where the asymptote always starts off the x-axis. So if I have moved down 6, my new asymptote should be down here at -6. Draw the asymptote always as a dotted line. Alright, so now all you have to do is draw a smooth curve approaching the asymptote and passing through these points. Now this is very tough to do with an electronic pen. I'm going to give it a try. I may fail. Make sure your graph goes all the way to the edge of the grid. So by the time the graph gets over here approaching this asymptote, all along the end it's going to really appear to be tracing this asymptote until it gets close and starts coming up. So it's okay that it appears to trace. Okay, and of course mine is going to disappear all the time. I have no idea why it does that. If anybody can leave me a comment explaining why my graphs disappear and how I can fix it, then I would appreciate that, because that's annoying. Okay, I'm going to have to draw my graph off camera, but it's just going to go like this and go through like that. I don't know how many times I'm going to have to draw it before it will stick, but I'll probably be old and dead by then. Alright, so your graph should look something like that. Alright, and that was number 7. Now let's take a look at number 8. Okay, for number 8, again I'm going to make my table of values. Okay, so I have -2 to the x minus 1 power plus 4. So when I first start out, I'm just going to do 2 to the x power. That negative sign I'm going to treat like a -1, and I'm going to do that later. So right now we're just going to do 2 to the x power. So on my chart, for my x values, I'm going to do -2, -1, 0, 1, and 2. And again, for my y values, right now I'm just doing 2 to the x power. Alright, now that's the same thing I had on the previous problem. So I already know what it's going to be, but I'm doing, so 2 to the x power, so that means 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 squared. 2 squared is 4, 2 to the 1 power is 2, anything to the 0 power is 1, and these are going to be reciprocal. So if this is 2, this will be 1/2, which makes sense with the -1, and then the reciprocal of 4, so this will be 1/4, which makes sense because it's 1 over 2 squared, so that should be 1 over 4. So anyway, and you know, if you watched the last video, you already saw me do that. So kabam! Now, where do I go from here? So I've done 2 to the x power. But now I need to deal with that -1 in front. So -1 is my a value. And when you have an a value, that means you need to make a new y column. So that's what I'm going to do. I'm going to make a new y column. Alright, and in that y column I'm going to do -1 times y, because that's my a value. So if I do -1 times all of these, they're just going to change signs. So I'm just going to have negative 1/4 and negative 1/2 and negative 1 and negative 2 and negative 4. Once you make a new y column, go ahead and throw out the old y column. Okay, notice I have not done the -1 or the +4 yet. I'm going to do that later. But let's go ahead and start plotting these points. So I'm going to graph -2 and negative 1/4. Okay, so -2 and negative 1/4 would be right here. And then I've got -1 and negative 1/2. So -1 and then negative 1/2 would be about there. Then I've got 0, negative 1. So here's 0 and here's negative 1. Alright, and then 1, negative 2. 1, negative 2 would be right there. And then 2, negative 4. So 2, negative 4 would be right here. Okay, so I have those 5 points showing me what the shape of the graph looks like. So I have done the 2 and I've done the negative. Notice it is reflected over the x-axis. But now I need to deal with the -1 and the 4, which I will do on the graph. So remember what the -1 and the -4 mean. Alright, the -1 means we're going to be going to the right one. And the +4 means that we're going to go up 4. So it's the opposite of this. So right 1, up 4. So I'm going to move each one of these 5 points right 1 and up 4. Okay, so right 1 and up 1, 2, 3, 4. Okay, and then this will be here, and this will be here. Okay, and then this will be here, and this will be here. Alright, each point is moved right 1 and up 4. Like looking at this point, for example, if I went right 1 and up 4, then it's going to land right there. So that gives us this. Now remember, the asymptote is normally here at 0. If I am moving up 4, then the asymptote, the horizontal asymptote, should be here at 4. Always draw your asymptote as a dotted line. Okay, so your graph should look something like this. Alright, so that was number 8. So one more. Let's do number 9, and then we'll put a stop to this video. Alright, 1/3. So the first thing we're going to do when we make our table is do 1/3 to the x power. So as usual, we'll start with our x's, which will just be -2, -1, 0, 1, and 2. So for our y values, we're just doing 1/3 to the x power. Alright, this seems too bold. Alright, we're just doing 1/3 to the x power. So that means we're doing 1/3 to the -2 power, and 1/3 to the -1 power, 1/3 to the 0 power, 1/3 to the 1 power, and 1/3 squared. 1/3 squared is just going to be 1/9. Square the 1, square the 3. 1/3 to the 1 power is just going to be 1/3. Anything to the 0 power is 1. Now these should be the reciprocals of these. So the reciprocal of 1/3 is 3. The reciprocal of 1/9 is 9. Now, why does that make sense? When you do a fraction to a negative power, you do the reciprocal. So this would be the same thing as 3 squared. which is 9. Because of the negative power, again, I would do the reciprocal. So this would be the same thing as 3 to the 1 power, which is 3. So it does make sense. So now we need to look and see, is there an a value, in which case we will need a new y column. All right, is there a number in front? No, there is no a value. So I'm not going to need a new y column, which means I can go ahead and start plotting these points now. So notice I have not done anything with the positive 2 and the negative 4 yet. I will do that on the actual graph. Okay, so let's go ahead and graph negative 2, comma 9, for example. All right, so negative 2, 9 is going to be right here. And then I've got negative 1, 3. So negative 1, 3. And then 0, 1. So 0, 1 is right there. And then 1 is 1/3. Okay, so at 1, 1/3 is just a little ways up. And then 2 is at 1/9. Now 1/9 is so tiny that it's going to appear to be on the line. Okay, but in your mind you just have to know it doesn't really touch. So those are the 5 values that we have to work with. All right, now we're going to do these transformations, the +2 and the -4. The +2 has the effect of shifting the graph left 2. It's the opposite of what it looks like. And this -4 is going to move us down 4. So I'm going to go left 2, down 4 with each one of these points. Okay, so left 2, down 4. Okay, left 2, down 4. All right, left 2, down 4. And, okay, left 2, down 4. And left 2, down 4. Okay, so these 5 points give us the shape of the graph. In fact, these are the final points. The horizontal asymptote is normally here at 0. Because of the -4, because it's down 4, we will have our new asymptote will be down here at -4. So always draw the asymptote as a dotted line. So I'm just going to draw my asymptote here as a dotted line. Okay, and then let's go ahead and draw the curve going through these points and approaching the asymptote. Make sure your curve goes all the way to the edge of the grid. So at the end, it's going to appear to trace, and that is okay. That's bending a little too much. All right, you know what? Let me try to do that over again. Okay, I'm just going to change the color a little bit and make it a little less bold. All right, so your graph should look a lot like this. And that's it for number 9. So that's a good place to stop this video. Wait, I spoke too soon. We need to squeeze in these last two problems that pertain to two of the problems that we just graphed. So number 10 here says give the following characteristics for problem number 9 above. Domain, range, horizontal asymptote. So problem number 9 is this last one. So let's talk about the domain and range of this graph. Well, the domain is the x value, so that's left to right. This graph goes left forever, and it goes right forever. So the domain is going to be negative infinity to positive infinity. That is too bold, so let's forget about that. And just tone it down. Stop acting crazy. Alright, so it's going to be negative infinity to positive infinity. Now the range, that's y value, so we're going to go from bottom to top in that order. Bottom first and then the top. So looking at problem number 9 here, does this graph go down forever? No, there's a floor right here. The asymptote is the lower bound. So this asymptote is at -4. So the graph starts from -4 and then it goes up from there. It appears to touch, but it really doesn't. We know that it's an asymptote. So the range is going to start from -4 and then it goes up to the sky. So -4 to infinity. Be sure to use parentheses, not a square bracket. That indicates that the -4 is not actually included. Again, because we know that in asymptote, the graph gets closer and closer but never reaches -4. Okay, what's left? What is the horizontal asymptote? Well, the horizontal asymptote is this horizontal line at -4. Horizontal lines always have the equation y equals something, so in this case that'll be y equals -4. Okay, so that's all about problem number 9. Number 11, we're supposed to state the end behavior for problem number 8 above. Okay, so the end behavior for this middle one, number 8, end behavior is all about what happens on the left and what happens on the right. On the left, the graph is approaching the asymptote. So on the left, we're approaching 4. On the right, the graph is dropping forever. So on the right, it's approaching negative infinity. Okay, so end behavior always starts off the same way. We say as x approaches negative infinity, that just means as you go to the left, f of x approaches, okay, these are y values, but as we go to the left, the function approaches the asymptote at 4. So I'm going to put 4. Okay, and then I'm going to say as x approaches positive infinity, meaning as we go to the right, the function approaches. All right, this is a y value. So as I go to the right, the function goes down, 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 down. So that's negative infinity. Okay, now, this is a good place to end the video.